Hey folks, Mr. Dell here. We are looking at a problem that has to do with scaling, scale factor, ratios, proportions. So this is a problem I'm taking from CPM's course 2, and this is section 9.2.3, specifically number 9-79. It says Glenda made, so I'll read it. Glenda made a scale model of the Empire State Building in New York. The building itself, so the Empire State Building itself, is 1,250 feet high. And her scale model, is 5 feet high. Write a ratio that compares the heights of the two buildings. So I want a ratio, right, of the two buildings. So my ratio comparing the heights, oops, I don't put it in there. So the ratio that compares the two heights would be written as a fraction, right? We would say it's 1,250, excuse me, 1,250 feet. That's the Empire State Building over 5 feet, and that's the model. So that's that ratio to compare the height of the original building, the actual building, to the scale model. All right. And then what we can do is we can actually simplify that ratio, right? And that gives us kind of our unit rate, if you will. So if I simplify this, I can actually divide top and bottom by 5, a giant 1 of 5. So that's why we end up with 1 on the bottom. So there are, and then I divide that by 5. I believe, let's see, it is 250. Yeah. So 250 feet per 1 foot. So for every 1 foot of the scale model, there's 250 feet in the actual real building, right? That's our scaling right there. So it says if the doorway of Glenda's model is 2 inches wide, how wide would you expect the doorway of the real building to be? Write a excuse me, write a proportion and solve. Okay. So what do we know? We know that the building has a scale factor of 250. Every 250 feet is 1 foot, right? So it's the scale factor, we could say. Scale factor, okay, is equal to 250 to 1. That's our scale factor. So if the model is 2 inches wide, how wide would the doorway of the real building be? So if it's 2 inches, my scale factor is 250, right? So we would say that I can take and multiply this by 2 over 2, because that tells me now that when it's 2 in the bottom, it's 500 in the top. But now we're dealing with inches. So I can take my scale factor, because here was feet to feet. So it's going to have the same scale factor if I made them inches. Because to make this inches, I would just multiply everything by 12. And again, we would be back to reducing it 250 to 1. So because it's the same unit, it's the same scale factor I can use. So every 500 inches in the real building is 2 inches in the model, right? So this is the actual to model, right? Remember that. So this is the actual to model is what we're dealing with. Inches in the actual versus inches in the model. So how wide? Well, we can just say it's 500 inches wide. I mean, that would be suffice, because it didn't say to put it in feet or, inches wide. But if we were going to put that in feet, we would take that 500 and divide that by 12, and it would be 41, or you could say 41 and 2/3 feet. So it's 500 inches wide or 41 and 2/3 foot wide. That's a couple good answers. And then if you guys, I guess if you really wanted to, you can make that into inches as well, and that would be 8 inches. So, or we could say 41 feet and 8 inches. So that's another way to mark it. Okay. C, last one. If the real building contains 102 floors, how many floors should Glenda's model contain? Well, floors, that's not necessarily a measurement. That's just a part of the actual building, right? So we're not going to actually use our scale factor on this, because we're not scaling the number of floors, we're just scaling the size. So I would answer that this would mean that the actual building would also make sure it contains 102 floors, because that's not changing, right? The that's you're not scaling down the number of floors, you're just scaling down the size of the floors. All right, there we go.